Hello and welcome. Today we're going to be talking about this problem. So this particular problem, we're asked to find, we've got a Skycam, it's 20 kilogram weight, and for those of you who don't know, a Skycam is usually used at sporting events. It's a camera mounted on some pulley systems. It's got 3 cables supporting it, and it allows the camera to kind of fly over the action in the sporting event. So we've got the 20 kilogram Skycam. We've got 3 cables supporting it with T1, T2, and T3. At 3 different angles, and in this 3D space, we are supporting the weight. We're assuming that the body's in equilibrium, so we're asked to find the 3 tensions in this cables that are supporting this 20 kilograms of mass. So we know this is a particle problem because everything will be traveling through the same point. So all the tension forces, if I draw in some of these tension forces, they are all traveling through the one point here, and the other force that we don't have shown on the diagram is going to be the mass, which we're assuming is going straight down. So everything is going through the central point. I know that I don't have any moments about that point. However, I do have forces in all 3 directions, x, y, and z. So first thing we do with any of our equilibrium problems is to draw a free body diagram. I'm going to draw a diagram of just this little dot, the connection point between the camera and the cables. So I draw in my little dot, and now I need to draw in the forces. So I'm going to draw in the weight force first. So it's a 20 kilogram mass. To convert that to newtons, a weight, I multiply 20 kilograms times 9.8 newtons per kilogram, and that gives me a weight force, which is going to go straight down in the negative y direction, of 196 newtons. Alright, so that's our first force. We've also got these tension forces. So I've got T1 going off at an angle like so, and T1 is in the xy plane, so Z is kind of going out of the board towards you, and this T1 force is just in the plane of the whiteboard itself. And it's at an angle of 15 degrees. Next I have T3 is the next thing I'm going to look at. It's also in the xy plane. It's kind of pulling the other direction. And that is 10 degrees above the x-axis. And the complicated one here is going to be T2. So T2 goes back like this. It's not in the xy plane. So it's actually, you can think about it going back into the board. It's in the negative z direction. And it is going to be 15 degrees. I'm going to draw in like so. 15 degrees above the horizontal xz plane. And this line here in the xz plane, it is going to be 60 degrees from the negative z direction. So this is going straight back into the board, and we're 60 degrees from that. So with that, I've got the angles all defined. I've got my known force, my weight, and my 3 unknowns, tension 1, tension 2, and tension 3. So with this, let's start writing the equations of equilibrium. All right. So starting in the x direction, we could do that. But actually, I'm going to take a separate step here first. So because T2 has an x, a y, and a z component, I'm going to go ahead and figure those out first before I start dealing with my equations. So in the y direction, let's use purple as something different. I've got this triangle right here, and I know the vertical part of that is going to be the y direction. So Ty is going to be T2, or sorry, this is T2y, is going to be T2, since it's the opposite, it's going to be sine, times the sine of 15. And the horizontal part I'm going to call xz. So T2 T2xz is going to be T2 times the cosine of 15 degrees. All right, I need to further break this down into x and y components. So I know this 60-degree angle here, and this right here, this part that's kind of on the xz plane is T2xz. So if I draw in a triangle like so, that's my right triangle. I know that this part right here is 60 degrees. Sorry, this should be horizontal, like that. And so the x direction, this is going to be x. So the x direction is opposite. It's going to be negative, and this is 60 degrees. So opposite is going to be x, and times T2xz. So T2x is going to be negative T2 cosine 15, which I pull straight down from there, times the sine, since it's opposite, of 60 degrees. All right, so there's T2x. Now I want T2 in the in the z direction. So z direction, I'm looking for this part right here. It's the adjacent side. So I'm going to do, again, it's negative because the z direction is positive coming out of the board, negative going into the board. So T2, negative T2 times the cosine of 15. That is the hypotenuse of my triangle, times the cosine of 60 degrees. And 60 degree cosine because it's the adjacent side. So now I have T2 in the y direction, T2 in the x direction, and T2 in the z direction. I'm going to use that in my formulas later on. So now I want to do sum of forces in the x, sum of forces in the y, sum of forces in the z. So in the x, all right, so x direction, I've got T1. It's going to be, I'm looking for this side right here. That is going to be adjacent, so it's going to be T1 times the cosine of 15. T2, I already went and figured out, so in the x direction, T2x is negative T2 cosine 15 sine of 60. And then finally, I've got T3, and this is negative, since its positive x direction is this way. So minus T3, and this is going to be the adjacent side on my triangle. So it's going to be cosine of 10 degrees. All right, and all of that is going to be equal to 0 because we're in equilibrium. All right, so sum of forces in the y. This is going to be a long one. So T1, I've got part of that going up. It's going to be the opposite side, so T1 times the sine of 15. And I already know T2y, so plus T2 times the sine of 15. And for T3, I'm looking for this vertical part of that triangle here. So it's going to be T3 opposite, so T3 times the sine of 10. And I also can't forget, I have a known, I've got this 196 Newton weight force pulling down. So minus 196 and this thing is in equilibrium, so equals 0. So there's my sum of forces in the y. Finally, I need sum of forces in the z. And again, the z direction is going back into the board like so. So in that, T1 has no component in the z direction. T3 has no component in the z direction. The weight force has no component in the z direction. The only thing that has a component in the z direction is this T2. And so sum of forces in the z direction is going to be equal to negative T2 times the cosine of 15 times the cosine of 60. And we know that has to be equal to 0 because this is an equilibrium. All right, so which of these equations do we start with? Well, we're going to start with this bottom equation down here because it's only got one unknown in it. It's only got T2. And so with that, I actually can pretty quickly solve this. So cosine of 15 is a number that's not 0. Cosine of 60 is also a number that's not 0. So T2 has to be equal to 0. And with T2 being equal to 0, I can go ahead and kind of cross out this part here and this part here. I know those parts of my equations are going to be equal to 0. So now let's go and look at the sum of forces in the x and kind of rewrite that. So for sum of forces in the x, or actually let's first look at in the y. So in the y direction, I know that T1 times the sine of 50, sorry, this is the x direction. I know that T1 times the cosine of 15 minus T3 times the cosine of 10 is going to be equal to 0. And I can kind of rearrange this and say that T1 is going to be equal to T3 times cosine of 10 over cosine of 15. I go back to my sum of forces in the y equation, and I can substitute this in. So for sum of forces in the y, I had T1 times the sine of 15 plus T3 times the sine of 10 is going to be equal to 196. I take this whole mess and I put it right there. So that gives me T3 times the cosine of 10 over the cosine of 15 times the sine of 15, which comes from right here, plus T3 times the sine of 10 is equal to 196. All right, at this point I've got one unknown, T3, and so I can solve this equation. I'll skip a lot of the intermediate steps here and just give you that if I solve out all these sines and cosines, I get 0.4375 T3 will be equal to 196. So that lets me know that T3 is going to be equal to 448.0 newtons. All right. So one last thing I need to solve for T1. So T1, I can use this equation here, will be equal to T3 times the cosine of 10 times over the cosine of 15. So if I take this number, 448, multiply it by the cosine of 10, divide by the cosine of 15, I can get T3 will be equal to T1 will be equal to the cosine of 456.7 newtons. And so with that, I've solved for all three of my unknown tensions. So I've solved my problem. And with that, thank you for watching, and I hope to see you again.